All right, so we have worked through all of our learning. We now understand that an average rate of change requires 2 points, but an instantaneous rate of change happens with a limit, and that makes those 2 points merge into one. So let's do some problems together and make sure we get it. All right, question number 1 gives us f of x is x squared minus 4x, and the question is asking for the average rate of change. All right, so that means no limits, right? We are just going to have 2 separate points. Remember, the fast way to do this is to put that function in your y equals in your calculator so that you don't have to actually figure out what f of -1 and f of 5 are, which is pretty handy. So average rate of change, here we go. We need f of 5 minus f of -1 over 5 minus -1. And that will give us a value of 0. Cool. So what that means is between these 2 points on our graph, they seem to be horizontal, right? So let's kind of just envision what that is that we just found. So let's say here's our graph, and let's say this is where our -1 value is. So this is -1 something, and this is where 5 is, and the slope between them is 0. Does that mean that's the slope everywhere between them? Nope. Just means the slope between -1 and 5 is 0. When we get to part B, we are now looking for an instantaneous rate of change, and we want it at 3. So I want you to make a guess. Do you think it's going to be 0? I don't know, but we're going to find an exact rate of change at one specific place. So to do that, we need to get our limit definition. So 3 is our A value. Here we go. So we begin with a limit because that's how we get instantaneous rate of change. And we're going to put first 3 plus h into our function. That's the first step. So we have 3 plus h squared minus 4 times 3 plus h. All right, so that is f of 3 plus h, and that's what we just put in our function. Then we're going to subtract the actual function value at 3. So if I put 3 into f of x, I get -3. We put all of this over h. That is my change in time. All right, now we need to do a little simplifying. So keep the limit notation there. Don't get rid of it. So limit as h approaches 0. So we are going to have, when we FOIL, 9 plus 6h plus h squared minus 12 minus 4h plus 3 all over h. Okay, so with any luck, some things are going to cancel. And I'm looking at, I have, let's see here, we've got 9, and we've got -12, and we've got 3. So those all make 0, so they're gone. And then I'm noticing that everything left has an h in it. So let's simplify this just a bit here. So we have the limit as h approaches 0, and this is going to be, we have 6h minus 4h, which is 2h, right? Minus h squared all over h. So if we try to plug in 0 right now, we get 0 over 0, but we know that's probably fixable, and it sure is. So if we take an h out of every term, this is where we are now. We have the limit of 2 minus h as h approaches 0. And now we can plug in 0 for h, and we get 2. So even though when we look on the interval from -1 to 5, we had a rate of change of 0, at specifically 3, the rate of change is 2. So we would have a positive slope at 3. Awesome. Okay, let's look at number 2. This one says, write but do not evaluate an expression that gives the instantaneous rate of change of this function at 2. So now our A value is 2. All right, let's set this up. So we begin with the limit as h approaches 0. We're going to first have g of 2 plus h. So that's going to look like -1 over 3, and then we plug in 2 plus h. we subtract the value of this function at 2. So if we put a 2 in, we have negative 1/6, and this is all over h. And there you have it. So that is our definition 1. And if we were going to simplify this, we'd have to use our algebra skills, right? But this problem doesn't want us to actually simplify it. They just want us to set it up. Now, we're going to actually also look at definition number 2. So if we were going to use that definition, it looks a little bit cleaner. What we do instead is we say, okay, we're going to set up our limit, but we're not using h. We're going to use 2 points, x and 2. And we want that x point to approach 2. So there's no h at all. We start with our function, negative 1 over 3x. We subtract the value of our function at 2. So we have negative 1/6. And we put this over x minus 2. And same idea, if we were actually evaluating it, we would simplify doing algebra and we'd get the same answer either way. So the idea here is you can find an instantaneous rate of change at a specific value using either definition. All right, finally, number 3. Which of the following gives the instantaneous rate of change at x equals negative 1? So this could be definition 1, this could be definition number 2. But the first thing to recognize is if it is definition number 1, your limit will have h approaching 0. If we're using definition number 2, we will have x approaching negative 1. So that means there are some I can cross off right now. This very first one on the left has h approaching infinity. Nope. The second one has x approaching a. Nope. The next one has x approaching negative 1. So we'll come back to that one. In the middle column, I see 2 of them that have h approaching 0, so those are possibilities. We also see x approaches negative 1 on the bottom, so that's a possibility too. And then on the right, we have h approaching negative 1. Nope. And then at the bottom, x approaching negative 1. So I've already eliminated 3 of my options just because the limit's not approaching the right thing. Okay, so let's take a look at the first column at the bottom. So remember how it should go. F of x minus f of a, numerator looks good. Ooh, but the bottom should be x minus negative 1. And we have x minus 1, so nope, that guy's out. Let's go right next door to the other x approaching negative 1. We have f of x minus f of negative 1 on top. That looks good. On the bottom, we have x minus negative 1. This is a keeper. Yes, this is definition number 2. Looks awesome. Okay, and then one more over in the right column, I see this x approaching negative 1. But look at that numerator. That's not how it's supposed to be, right? It's supposed to be f of x minus f of negative 1, and that's not right. So we've got one definition 2 so far. Now back to the middle column, definition 1. Both of them have h approaching 0. We want this to be specifically at x equals 1. So this middle guy, look what's going on there. We don't have the negative 1 there. We have an x. That's no good. But the one above it, we do have the right format. Negative 1 is the x plus h minus f of negative 1. So that one is also correct. So you are now ready to go to Delta Math and your practice worksheets and become an expert at this. I'll see you soon.